Question number 4 asks for the volume. The rule of the volume is, this is a concept that was in O-levels, but it was not in any of the previous papers. So this can be considered to be the first in C4. This is an integration sum guised as a volume sum. This is a common sum that will often be given, find the volume. The rule for volume is volume equals to integration of a limit pi y squared dx. Of course, this is a flat region. Flat region cannot have volume. Flat region have area. Area means space occupied by a flat object. But what they're actually saying, if you rotate this object, if you have this object here like this, now if you keep on rotating it on the x-axis, so what would happen, you get some sort of a solid like this. So it's mentioned if you rotate it on the x-axis by 360 degrees, you get a solid. That imaginary solid is the volume that they're asking for. Volume means space occupied by a solid object. So this sum is an integration by parts sum. It's mentioned here. Use integration by parts. Remember, in every C4 sum there is going to be 4 or 5 integration sum, and it is part of C4. Integration is the main topic of C4. So in order to do that, you need integration by parts formula. So this is the by parts formula. If you have u and the other term is dv by dx, and you have a limit a to b, then the formula is uv limit a to b minus limit a to b v du by dx and dx. That's the formula. And you should remember how to select u. U is based on LATE, so u equals to L for log or ln, A for algebra, T for trigonometry, and E for the exponential function. That's the sort of the ordering of how you select u. So let's start. So we have to find the volume. So formula for volume is volume equals to limit 1 to 3, limit is 1 to 3, pi y squared dx. So 1 to 3, the equation is y equals to x e to the power x, so x e to the power x whole square. If you break this down, limit 1 to 3, pi x is x squared, e to the power x whole square, x into 2 is twice x dx. Now it's a very good idea to write the pi outside the bracket and the integral separately, because this is a by part sum after all, and let's consider this as I. So volume equals to pi I being the integral. Then let's restart the sum. Therefore I equals to integration of 1 to 3 x square e to the power twice x dx. So the presentation could be like x squared by LATE, L for logarithm, there is no logarithm, A for algebra. So this is algebra. Algebra comes first, so that is our u. So we can do this rough work at the side. U equals to x squared, therefore dv by dx equals to e to the power 2x, therefore v equals to integration of this, which is e to the power 2x by 2, and we need the derivative in one step. So derivative of u du by dx is twice x, so this is the derivative and this is the integral. Let's get back. So u is going to be x squared just as it is, and v is going to be this one, e to the power 2x by 2. You can write it here, e to the power 2x by 2. Limit is 1 to 3 minus limit 1 to 3. Then we need v is going to be e to the power 2x by 2, and the derivative of u is twice x. This would be twice x, so put it in a bracket. Dx, we can cancel this 2 and 2. So let's simplify this. This is going to be 3 squared into e to the power 2 into 3 is 6 by 2 minus 1 squared e to the power 2 into 1 is 2 by 2. So let's put it here, minus. Now this is another integration. This is the integration of 1 to 3 e to the power 2x and x comes here. So this is another integral, and you know this is a very common integration by parts. If we simplify this, 3 square is 9, so 9 by 2 e to the power 6 minus 1 square is 1 by 2 e squared minus, let us consider this to be another integral I2. Get back and consider this to be I1 then. So v equals to pi I1 and I1 equals to this. We have another integration. Therefore I2, otherwise you know there will be so many brackets, it would be very confusing, so break the sum down. It's a very good habit. I2 equals to integration of 1 to 3 x e to the power 2x dx. Again u is this by LATE, this is algebra, this is dv by dx. Integration of dv by dx is going to be e to the power 2x by 2. Limit is 1 to 3. This is limit is 1 to 3. So v is going to be e to the power 2x by 2, and the derivative of x is going to be 1 dx. So this is going to be, if I put 3 here, it would be 3 by 2 e to the power 2 3 is 6 minus, if I put 1 here, it would be 1, the 2 is here, e to the power 2 into 1 is 2 minus the integration of e to the power 2x. The integration of e to the power 2x is going to be e to the power 2x by 2, and there is a 2 here. I am going to put it here as half, and the limit is 1 to 3. So this is 3 by 2 e to the power 6 minus 1 by 2 e to the power 2 minus, if I put 3 here, 2 to the 4, so 1 by 4 e to the power 2 3 is a 6 minus 1 by 4 e to the power 2 1s are 2. Now we can just open the bracket. 3 by 2 e to the power 6 minus 1 by 4 e to the power 6 minus 1 by 4 e to the power 6. Then we have minus half e to the power 2, minus and minus plus 1 by 4 e to the power 2. By simplifying this, 3 by 2 plus 1 by 4, 3 by 2 minus 1 by 4 minus 1 by 4, we get 5 by 4, so 5 by 4 e to the power 6. Then we have 1 by 4 minus half. If we take e square common, this would be minus 1 by 4 e to the power 2. Finally we need to get back and find I1. Therefore I1 equals to 9 by 2 e to the power 6 minus half e to the power 2 minus I1, and I1 9 by 2 e to the power 6 minus half, 9 by 2, this would be 9 by 2 minus half e to the power 2 minus I2. I2 is this one, 5 by 4 e to the power 6 minus 1 by 4 e to the power 2. See what I'm talking about? If you have done it in one line instead of I1 and I2, then it would have been very messy. It's a bad idea. You have to follow the good habits. 9 by 2 e to the power 6, then minus, let's bring all the e to the power 6 together, 5 by 4 e to the power 6 minus 1 by 2 e to the power 2, minus and minus is plus 1 by 4 e to the power 2. So this would be 9 by 2, 9 by 2 minus 5 by 4, this would be 13 by 4 e to the power 6, and 1 by 4 minus half is minus 1 by 4 e to the power 2. The sum will finally be volume. Therefore volume equals to, it was pi I1, so pi I1 is this, 13 by 4 e to the power 6 minus 1 by 4 e to the power 2. So that's the answer. The mark scheme shows, first we write v equals to pi like this, so m1, then we integrate by parts, 2 more marks, then we integrate the integrate by parts. It's an 8 mark sum, and finally the answer that we got is, alright, we got it. If you lose this pi, you're going to lose 1 mark, remember that. The examiners say there were many excellent solutions to this question, but too many who did not know the formula for finding the volume of the solid. Remember, too many means a lot of people. Candidates who successfully evaluated this were able to gain 6 out of 8 marks. Even if the formula used was this, they got 6 marks. Remember, don't think even if you are not able to do the full mark, you will lose the mark. You're going to get a lot of marks, 6 out of 8, even if you lose the pi, remember. But there were many candidates who made errors in integration. This is a basic integration, x e to the power x. Remember to practice this, ranging from the slips like sign errors, numerical errors, so arithmetic error, integrating by parts in the wrong direction, an error with serious consequences for most who made it was to write x e to the power x whole square as x squared e to the this is a C1 problem. Remember, if you have e to the power x whole square, it is e to the power 2x, not e to the power x square. For some it was merely a notational problem and something could be salvaged, but for most it presented a tricky problem. Remember, do the sum, break it down as I1 and I2. That's a good suggestion by the examiners. This is a partial fraction sum. Remember, in C1 we had algebra, quadratics, linear. In C2 we had cubics. In C3 we had to simplify an expression. In C4 we do the opposite. We take a simplified expression and break it down into the previous format. In C3 we do this and made it into a single expression like this. This is a simplified version, but here in C4 we take this simplified expression and break it down into this. So let's begin. For doing partial fraction, all you do is write this out: 3x squared plus 16x 1 minus thrice x 2x plus 2 plus x 2 plus x. This would be a by 1 minus thrice x plus b by 2 plus x plus c by 2 plus x whole squared. For the LCM, all you have to do is just copy this here. This is square here, 2 plus x squared. Just copy it here. So 1 minus thrice x 2 plus x whole squared. So this and this matches. So this would be a into 2 plus x whole squared plus this into this matches, b into 1 minus thrice x 2 plus x plus, for c, this thing and this thing matches, it would be c into 1 minus thrice x. Okay, now downstairs and downstairs matches here, so upstairs would be equals to upstairs. So 3x squared plus 16 is equals to a 2 plus x whole squared plus b 1 minus thrice x 2 plus x plus c 1 minus thrice x. That's it. Now we want to make the other ones as 0 and find the values. For doing that, we take the factors. Now there are actually two factors because 2 plus x is repeated here. 2 plus x, 2 plus x whole squared. So we actually have two factors. By taking 1 minus thrice x equals to 0, we get x equals to 1 by 3. By taking 2 plus x equals to 0, we get x equals to minus 2. So we have two values to put here. For x equals to 1 by 3, putting this value, this left hand side would be 1 by 3 whole squared plus 16. This would be a 2 plus 1 by 3 whole squared. This would be 0 because this thing is equal to 0 now, plus this would also be 0. So that means 1 by 3 whole square is 1 by 9. So 3 by 9 is 1 by 3 plus 16, and this would be 3 to the 6 plus 1, 7 by 3. 7 by 3 whole square is 49 by 9. Therefore 1 by 3 plus 16, 16 3s 48 plus 1 49, so 49 by 3 equals to a 49 by 9. Seems to be going in the right direction. Therefore if I cross multiply, it would be 49 into 9 divided by 3 into 49 equals to a 49 49 cancels, 3 3s are 9, therefore a equals to 3. Next let's put b equals to minus 2, x equals to minus 2. For x equals to minus 2, 3 minus 2 whole squared plus 16 equals to, now this one if you put minus 2, this term becomes 0. This term equals to 0 as well because there is also minus 2 here. If you put it in this term, it would be 1. Minus 3 into minus 2 is plus 6. So minus 2 square is 4, 4 3 is 12, so 12 plus 16 equals to 6 plus 1 7, 7c. Therefore 1 plus 1 2, 28 equals to this, therefore c equals to 28 by 7 is 4. So a equals to 3, c equals to 4. We have run out of the terms that we can take as x. We took 2, x equals to 1 by 3 and x equals to minus 2. What about the other variable b? For that you have to take a dummy variable, and the simplest and the easiest is x equals to 0. So let's put x equals to 0 by ourselves. Let me do it here. For x equals to 0, what we can do is, if we plug in x equals to 0, this would be 3 into 0 square is 0 plus 16, so this would be 16. This would be a, 2 plus 0 is 2, so 2 squared, plus b, 1 minus 0 is 1, 2 plus 0 is 2, and plus c, 1 minus 0 is 1. 16 equals to 4a plus 2b plus c. Therefore 16 minus 4a minus c equals to twice b. If I put, so a equals to 3 and c equals to 4, so 16 minus 4 into 3 12 minus 4 equals to 2b. 16 minus 12 is 4, 4 minus 4 is 0, so twice b is 0, therefore b becomes 0. That thing makes things easier. Let's get back and write the whole expression. Therefore let me call this fx. Fx equals to 3 by 1 minus thrice x so a by 1 minus thrice x plus b is 0, c by plus 4 by 2 plus x whole squared. That's the expression. In b, usually what we have here is we have to integrate this partial fraction to break down, and this is the most common, but in this particular sum we have to express fx as the binomial expansion. Binomial expansion is a concept from C2 where we have 1 plus b to the power n, we break it down as 1 plus nc1 b to the power n, b to the power 1, nc2 b to the power 2, nc3 b to the power 3 plus dot dot dot, and this means it goes on forever, but we stop as an approximation of the terms. nc1, nc2, nc3 can only be written if n is natural number. N is a natural number. That's what happens in C2. Natural number means 1 2 3 4 5 6 7 8 9 10 and on and on. However, if n is negative, or if n is a fraction like in case of C4, in that case instead of nc1, if you write nc1 then it will be wrong. Instead of nc1 you write n. Instead of nc2 you write n minus 1, 2 into 1. Instead of nc3 you write n minus 1, n minus 2 divided by 3 into 2 into 1. So that's the rule that you have to follow. Let's do question number B then. B, in order to express fx in terms of x, we have to bring this upstairs, so 1 minus thrice x to the power minus 1. Then we have to bring this upstairs, 2 plus x to the power minus 2. Now we need to expand this. Expanding 1 minus thrice x to the power minus 1. In the question they had asked for expand including the term x cubed. So this is going to be plus 27 x cubed plus dot dot dot. Next we have 2 plus x to the power minus 2 expanding 2 plus x to the power minus 2. Remember, you cannot expand it unless this is 1. So we have to take 2 commons. It would be 1 plus x by 2 and the whole power is minus 2. Be careful about this. So 2 to the power minus 2 and this would be 1 plus x by 2 to the power minus 2. So this would be 1 by 2 square, meaning 1 by 4. 1 plus NC1 is n, b is x by 2 to the power 1, NC2 is n minus 1, 2 into 1, this is x by 2 to the power 2, then n minus 1, n minus 2, this is 3 into 2 into 1, is x by 2 whole square, whole cubed, plus dot dot dot. So 1 by 4, let's keep it here. So this is 1 minus 2 by 2 is minus 1, so minus x. Then this is minus 2, this is minus 3, so this is going to be 6 by 2 is 3, so this is going to be x by 2 whole square, so x squared by 4, so 3x squared by 4, so 3x squared by 4. The next one is, this is minus 2, this is minus 3, this is minus 4, so 6 into minus 4 is minus 24, minus 24 by 6 is minus 4. Now 2 cubed is 8, so minus 4 divided by 8 is minus half. This would be minus half x cubed. Now fx, therefore fx equals to 3 times the first expansion plus 4 times the second expansion. I recommend you keep the 1 by 4 outside because it will cancel off. So 3 times the first expansion was 1 plus thrice x plus 9x squared plus 27x cubed plus 4 times, now this one is going to be 1 by 4, 1 minus x plus 3 by 4 x squared minus 1 by 2 x cubed. So this 4 and this 4 cancels, this would be 3 plus 9x plus 27x squared plus 81x cubed plus 1 minus x plus 3 by 4 x squared minus half x cubed. Now 3 plus 1 is 4, 9x minus x is 8x, 27x square plus 3 by 4x square, so 27 plus 3 by 4, it's going to be 111 by 4, 111 by 4 x squared plus 81 minus half, if you take x cubed common, 81 minus half, that means 161 by 2, 161 by 2 x cubed. So that's the expansion. So the value shows a equals to 3, c equals to 4, b equal to 0, that is correct. Then the answer is 4 plus 8x plus 27 whole, this is also correct. Remember, this is just the mark scheme. You're not expected to present your work like this. You present the work in the natural way, so you have to follow the examiner's report for that. So here we have, this was a high scoring question for candidates. That's good, with even weaker candidates often picking up half marks. A problem in part A was that some candidates used the fact that b equal to 0 to find A or C or both, especially by candidates who compared coefficients and found themselves getting bogged down. Remember, you can do the sum in different way. It is recommended that you follow their way by the substitution. This is the easier. They always recommend that. They don't force you to do something, but it's a good idea to follow their way. So x equals to minus 2, x equals to 1 by 3 is the best way. Then in the binomial expansion, it's always a good idea to break it down into smaller segments. So it did cause problems. This one, you have to take 2 to the power minus 2 is the common. Remember, that's a very common mistake, so remember that.